All right, guys. Hope you can hear me. Please give me thumbs up if you can hear me. Give me thumbs up if you can hear me, please, so that we just start immediately. Great, great. Yeah. Welcome to today's class. This is the week 6. This is the final week of our course. So far so good. To God be the glory. We have. I believe we've gotten something out of this course so far. Um, it hasn't been easy for, I believe, for us, trying to learn all those long hours of tutorials and videos as well, 3 hours and the rest. So one thing is that if we are consistent and we just follow with the tutorial, we're going to get something out of it, right? So basically today, week 6, the Saturday, by tomorrow will be the Sunday part of it, and it will be the final week, the final day. So today we'll be looking at Kafka, Apache Kafka technology. We'll be integrating it into our system, to our project, and we'll see how it works or what it actually is for. Then tomorrow, Sunday, we'll be looking at Nest.js, right? So Nest.js will be the final technology we'll be looking at. Nest.js, basically, we're going to discuss Nest.js, the component, and everything that we'll have to transfer our project, convert our project to Nest.js, and it's going to be a very easy transfer for us. Like convert everything. You're going to see how it works, and we'll have to compare the two and see their similarities and their differences, right? So basically, today Kafka, we'll just discuss it, show us something. It just kind of, to me, it's Kafka is not too complex. It's just very straightforward. It's just the name that makes it kind of look terrifying, but it's okay, right? So that being said, our lab, we're going to continue from last week. I believe last week we stopped at Redis, right? We discussed Redis. We tried to we integrated Redis into our application, right? And we ran with Kafka, with Docker and everything. And we also discussed about Docker Compose, how we, questions on Docker Compose, how to, Dockerize and everything. So I think we are good on that. If you have any question, we can ask, right? So now we'll be looking at Kafka. I'm going to open some, do some googling on Kafka. I think I have some resource here. Yeah, so I figured instead of creating slides for it, I can just use something already on the internet. Just have a look and discuss. So basically, what is Kafka, right? Now, this is what I thought when I was preparing this course. When you design your backend server, right? Basically, you design it like what we have now. If you follow through the course till now, you are a backend developer, quite right. You're a backend developer, no doubt about that, right? So now the next challenge for you is that, okay, are you a backend developer that will just build applications that don't scale, right? We are looking at scalability, right? Scalability now, right? How to scale your applications and the rest. And these two technologies that I've been discussing, basically Redis and Redis we discussed last week, and Kafka that we are going to be discussing today, they are basically one of the most they are basically two of the most discussed technologies to scale your applications, right? So what do they do? Like Redis, when you want to do heavy reading, like if you want to optimize your reading, yeah, reading of data, right? You use Redis. Redis help you to, to scale reading logic, because it catches any frequently accessed data and helps you read it fast. All right, it has to do with reading of data fast, right? Now, what does Kafka do? Kafka now has to do with writing, like writing of data to your database system. right? So you have to optimizing read logic, I mean write logic in your application. That's what basically what Kafka do. So you can see the two: Redis for read, Kafka for write, right? So basically what I would be demonstrating here is there are some scenarios whereby you they will tell you to, as a backend developer, they will tell you, okay, give us an API that will send a large volume of data to update your database, your system, right? If you build a simple API like just your normal API and you send it, if they call that API, the API is going to lag. Maybe the data, you need to do some background cleaning or some enriching of that particular data. Let's say, for example, if they send you that data, large volume of data in array per se, they send it to you, and when your application is processing that data, it has to do some background processing, right? It has to, maybe if it's let's say 100,000 of data, data in hundreds of thousands. Now you have to start, processing individually one of them, probably calling under extra calling external APIs to, to clear or maybe to enrich that data. Now, if your application is processing those data one after the other, that API is going to lag. Of course, it's going to lag, and it's going to be terrible. It's going to be a terrible experience, right? This is actually what I'm saying is actually from experience. It's actually from experience. There's a project I worked on. In fact, we are optimizing the API now to version 2 so that we're able to optimize the writes. The one we got was kind of lagging. It wasn't optimized, so I had to integrate Kafka to optimize the writes logic, right? It's kind of a big chunk of data. It receives big chunks of data and process it, do a batch processing on it. So basically, that's just the whole idea of why we are using Kafka, right? To optimize read, to optimize write logic of our applications. If you have any API that you want to, if it's just a normal API that you just want, just inserts the normal insert logic, maybe just to register a user, you don't need Kafka for that, right? But if you need something to write to process a large volume of data, that's when you start start thinking of using things, technologies like Kafka, right? So let's have this is on tutorials points. So let's look at what Kafka is. Right, so this is it. They say in big data, an enormous volume of data is used. Yeah, you understand. Now, regarding data, we have two main challenges. First challenge is how to collect large volume of data, and the second challenge is how to analyze the collected data. To overcome those challenges, you must use messaging system. Yes, basically Kafka is, yeah. So Kafka is kind of a messaging system, right? Yeah. It's, yes, you call it a queuing system. You guys to queue, and it's basically it's a messaging system, right? So it's used to process large volume of data. So the idea behind Kafka is that when you give it a large volume of data to process, it starts queuing your all the jobs, each of those data. It queues them, put them in a queue, message queue, right? It sends them into a message queue. Then there's what we call consumers. We have producers and consumers. Producers will send data information to the queue, while consumers will process data from the queue, right? Basically, that's just the fundamental, that's just the knowledge there, right? So we call it publish and subscribe messaging system. So it pops up, we can call it pops up. So basically it's just like a queue, you put just like a queue. Yeah, the sender, which is the producer, sends data. These envelopes are kind of the data or the jobs that you want to process. You send them in, then the receivers, individually, one of them, you have multiple consumers, and the rest they will process, take jobs from the queue and start processing, right? Now Kafka is a distributed publish subscribe messaging system and robust queue that can handle high volume of data, right, and enables you to pass messages from one endpoint to another. So basically, yeah, when they say distributed, it's kind of like you can have multiple engines running together, right? For Kafka, there's a way you set it up. You have multiple engines running together. So we're going to see a picture of that now. So basically, this is the whole architecture of Kafka. So guys, hope you can see my screen. Oh my god, I am not sharing screen. Oh my I thought I've started sharing my screen. Sorry guys, sorry. Hope you can see my screen, right?
Yes, we can see you.
Oh, sorry guys, I thought I was sharing my screen. Oh. All right, so what I was saying is that Kafka, it's kind of a messaging system, messaging queue system, right? Where you have two entities. One entity we produce, or one logic we produce um, a job or a data into a queue, and the receiver will the process consumer or receiver will take the job or the data from the queue and process it. So it's kind of like in a queue system, right? So when you give Kafka that large volume of data to process, it just straighten everything and puts it in its queue to be processed one after the other, right? So basically just like a messaging queue system. So they will call it publish and subscribe messaging system. And what it means is that the when you put it has a queue, yeah. Kafka has a queue. When you put data inside the queue, we call it publish. You are publishing data inside the queue, right? Then when the receivers, the logics or the function that you're going to write that will process those jobs or those data from the queue, when they will receive the when they receive the data to process, we're going to call it a subscribe system, right? Subscribe logic. We're going to see everything in demonstration, right? So basically, the whole architecture. This is how Kafka is, right? This is the whole architecture, right? When you download Kafka into your system, this is the whole thing that you're downloading. This is the whole architecture, the way it looks like. You're going to have producers, right? You can call the producers are the senders. These senders we saw here, these senders that we saw here, they are the producers because they send jobs or data into the queue, right? Now, these are the producers, you call them senders also. Then these are the consumers or the receivers of message, right? These producers produce data into the queue, while these consumers consume the data from the queue, right? Now the queue logic. What's basically the queue? Actually, this is when you say the queue, we are talking about the brokers that handles that's helps you to keep track of those data that you're setting into Kafka, right? We call them the brokers, right? Call them the broker engine, the broker system. So here, this is we can have multiple brokers. Brokers is just like the queue, right? Queue. You can have multiple broker system, just like the whole body of the queue, right? So we have multiple broker. You can have broker one, broker two, and so many as you want, right? Then when you group those brokers together, you call them Kafka cluster, right? Kafka cluster. So basically, when they say Kafka is distributed, this is what they mean. Like you have multiple brokers that just be helping you to process the job. All right, multiple brokers, just like multiple servers or multiple engines of Kafka, right? So now inside each broker, when the producer wants to send message, the message that needs to be produced, that needs to be processed, the data that you want to process before you store it on your database, right? When the producer send it, it doesn't just set throw it inside the cluster or inside the broker, right? It doesn't just throw it there. It drops it into a topic. There's what we call topic, right? When you're setting up your Kafka, we're going to see this in demonstration. You're going to specify topics that you process, that you're sending the data into. Maybe you have data for processing payments. You have you have data that just this data have just payments processing, like you want to they are just to process payments, right? You're going to create a topic, Kafka topic, call it a Kafka payment or anything. Then you when you want to process a payment, you push that payment data into that payment topic, right? So everything will just have topic. Now inside the topic, for Kafka to optimize the whole process, it has to create, divide topics into partitions, That's why we have here we have topic A partition 0, topic A still topic A partition 1, right? So inside the broker 1, then in broker 2 you can still have this another topic or the same topic, and broker, it just everything is just like segregated, so that why Kafka do something like this is that it helps to it's just for optimization, to optimize the whole process, so that you don't have one of the methods of optimization is what would I call it, replications, right, creating replicas of different engines, and so that they can help you to manage to handle jobs as they come. So these are just replication logics to optimize Kafka implement processes. So basically, guys, this is just the overview. I know it's too much talk. Let's just go into demonstration and see how we're going to what we're going to be doing. So basically, if you want to install Kafka on your system, you can just Google Apache Kafka. Can go online, search for Apache Kafka, and you download it into your system, right? But we are not going to be using, we're not going to be downloading the software into our system. We are going to use Docker to run it, right? So we're going to run Docker the same way we run Redis with Docker. We're going to also integrate Kafka into our system, into integrate Docker Kafka via the Docker image, right? We're going to use Docker image. So let's go to Docker Hub and see the image that we're going to be using at the same time. All right, so if we go to, I don't know why my network is kind of slowing down. Sorry, guys. Okay, and let's let's come here. All right, let's look at the Docker image. Call it CP Kafka. Yeah, this is it. So this is Docker, the Kafka image. The Kafka Docker image we're going to be pulling. We'll use for our application. Right. Just come here. So you can just use this command, but we're going to integrate it into our Docker Compose file. I believe we already have something like that here. Right. So this is the setup. Right. So guys, hope you can see my screen. So basically, this is we have Redis here on the system. So when you are configuring services this way in Compose, you just follow this format. It's a well-known format. You specify the services. You can also specify volumes here at the down, but here we just specify services. Then here we specify Redis service, and we are pulling the image, Redis image. We are using Redis image, and we're going to name the container. When we start running the container, we're going to call it Redis. And restart logic is always do the port mapping. They also map the volume, right, the container volume to our local system, right? So which is here. It's going to create a volume directory here for us. Then we're going to do the mapping. Then we'll give it command. It's just generic, like well known. Then this zookeeper actually comes with this Kafka broker. Zookeeper is kind of like helps to manage the Kafka broker. Then As you can see, it's coming it's from the same group, same organization, Confluentic image. So we have the CP Zookeeper, CP Kafka, and the image here is still Confluentic CP Kafka. Then the container name is Kafka. Result logic is always, then depends on, yeah, this depends on, like, is the Zookeeper. So it means that this Kafka, we're going to use a Zookeeper, this the name here. We're going to use the Zookeeper for Kafka. So that's why it depends on. Then the port mapping, with the proper port mapping, and then everything is just will put this inside these environmental variables. So basically, guys, this is the settings we're going to be using for this demonstration. So our Kafka is going to be dockerized, and we map the volume here. We map the volume. So why we're mapping the volume is that when the container, when we dismantle the container, we stop the container, the volume, whatever we did, the volume will still be, the data that Kafka is we handle is still going to be within our project, right? So it's not going to be discarded with the container when the container stops running. So I'm going to share this with us. If we have any question on how, what they actually the content are, we can ask. So basically, just follow this format. When you're creating service, you name the image. If you're not using image, if you don't want to pull image, maybe you want to build the image from here, like for example, this is Docker Compose for development, for like as we're building our project. Yes, Docker Compose we're going to use. But if we were deploying our project to production, that means we need to also dockerize this our Express server, right? So if we want to do it, we created a Docker file for our Express application. Then the production file is this. If you check here, we also dockerize our Express app, right? So we, for the image, if you look here, there is no image here. We didn't specify any image, just like we did here. There's no image for the blog server app. What it means is that we are dockerizing it here. We are not using any, we are not pulling any image from Docker Hub. So the specification is going to be different. So if you see here, we specify build. So we say we're building it here. Docker Compose, we know that we are building this our service here. Then the context is this. What it means is that whatever we want to use to build this application is in this folder. This dot means this current directory where this Docker Compose is. Then the Docker file you want to use, because when you want to build your image, you must specify the Docker file. The Docker file is this. So the Docker Compose, we know we have to look for the Docker file to use. Then the name of the service will be this. Then restart logic, everything just follows as before. Depends on, meaning that our app is going to depend on Redis service and Kafka service. Then the port mapping, then we specify the env file, then the environmental variable. So basically this is, and everything just follows as before, right? Here we specify the volumes mapping, because we don't want to use the way we map our volumes. So basically, guys, this is just the how to integrate Kafka now. So basically, we have if we start our Docker Compose, we have Kafka running for us to integrate. Right, we have the Kafka engine. So instead of downloading the the software, just here, instead of downloading it, we just use the Docker image to build and to run it. Right. So let's go ahead. Now, how do we run this? If I do now inside my terminal project, I've not integrated, right? I've not integrated Kafka into our project. We're going to do that, but let me first run it so that you guys will see. If I do docker ps, okay, no, let me stop all this. So I already have them running, but let me stop them on. I need to stop all of them. Yeah, ID. I want to stop all these Docker containers that are running so that I can start them up again. Then we'll see how uh, they are being done. It's taking time. Okay, these are the images and these are the containers that are running. Come here. Okay, then let's stop this one. The next one, I'm using their Docker image, their container ID. Sorry, if you look at this, if you look at the terminal here, the container ID is this, the image the container is built from is this, right? This is the image, right? The one we specified in the compose. The command to start it is this, created at the time we started it. Status, the time it was created. Status is this, the port mapping is also this, and the name, if you see here, the name is supposed to be here at this side after the port, but because of there is no space, it came under. So what if you look at this is the name, this is the name here, it follows suit. The same thing for the next one, zookeeper and redis, the name, yeah, this is a name. All right, so what I'm going to use their, okay, let me use the name now. I'll use zookeeper. Let me use their name, zookeeper's name to stop it. All right, guys, when you start using these technologies, they will feel very familiar to you. So let me stop redis. Good. So if I do docker ps now, docker ps is to list all the containers that are working, currently running. So if we list them, don't know why this terminal is okay. As you can see, there's nothing listed, it's just the columns name, so there's nothing listed. So let's start up our container, our let's spin up all these services that we have here in the compose here, docker compose file. So let's spin up redis, zookeeper and kafka. Right, so we're going to spin them up right now. How do we do that? We just come here, do docker compose. Docker compose means we want to run everything together. Now because we don't, our file here is docker compose.dev dev.yml, right? Because I don't mean we remove this, I don't mean we have the name this way, right? We'll just do docker compose up, yeah, docker compose up, right? This hyphen means I don't want to see the log, it should just start everything in background. But if I remove this hyphen d, if I click enter, it will start when it's starting up the application. I'm going to see the log, how it's going to start up. But if I don't want to see the log, how they are being started up, I will just put hyphen d, right? That's background, right? But let me just leave it. I want to see how everything is being start up. So if I have this file here this way now, docker hyphen compose.yml, this command is enough to start up the whole services, to start up, to run this everything here, right? But because I specified the name, I added dot, let me read it, let me add the name, this in back, the ev, because I added dot dev, right? So the names now is now different. So because I did that, I'm going to add something here, -f docker compose .dev.yml. So I'm going to specify. So basically what I'm telling docker compose is that when you run docker compose without this hyphen flag, this f flag, docker compose will look for docker compose.yml, right? It will look for it and use it to start up the docker compose system. But if you did not specify, if you maybe alter the name, state it differently, you have to specify, use the flag, the f flag, to tell docker compose the file you want to use to start up the docker compose system. So that is why I'm using this flag here and this file name, right? So guys, if I click enter now, if the image is not already on my system, okay, Else conflicting names. All right, so I need to delete some containers. All right, they are not running. I need to remove them. So the containers are still in the system, and they are not, though they are not running. So that's why we got this error. It says it's check for zookeeper. It says conf, conflict name, conflict, the container name, blah blah blah, is already in use. Redis is already in use by container. So the name I specify, the names here are used by this container. So I need to delete the containers totally. So let me do for Redis. So no container can have two names. So if I delete them now, right. So if you check, I use Docker space stop to stop the containers. Then now I'm deleting them. I'm using remove rm, right. This is the container, not the images. The images are there, right. These are the images. The images I'm not deleting the images, it's the container, right. I hope you guys understand the difference between the image and container. Image is what you, when you build an image, when you dockerize your application, it means you built the application, right. You built the application into a Docker image. So from that Docker image, you can run the Docker, your application. When you run it, you are actually running it as a Docker container, right. So a Docker where you create Docker container, you can run it and stop it. It can be stopped, and you can run it and it can be stopped, right. And it can be deleted. Delete the container, right. When you delete the container, you can still build, create the container, run the container from that image, right. You still have to create the container from that image. But when you delete the image, you have to build it again, build the image again, right. So what I'm doing here now is I'm deleting the container, not the image. So if I delete the container, I can still rebuild the image, the container, or rerun the image, or recreate the image, the container from the image, sorry. So all right, let me do for zookeeper. So if I run this command now, see I added hyphen to check. Okay, there's no image, there's no container that is not running again. All the container, both running and not running, are deleted. So but if I, to check the images that we have on our system, this is the command docker image ls. If I click enter, it's going to show me all the content images. So these are all the images that we have on our system. These are the two, the zookeeper and the Kafka, right. Kafka and zookeeper and Redis. So I'm going to rerun this docker compose now. We're going to see, it's going to start up all the images, all the it's going to build the containers from the images again now. Docker compose.dev.yam up, docker up. If I click enter, I start, see it's creating, it has created the container. Container zookeeper created, container Redis created, container Kafka created, right, attaching to Kafka, Redis and everything. So it's creating, this is the whole process it's going to take. Sorry guys, I need to plug this system now. Alright, so everything is up. It's up. Let me open another terminal here and show us. So guys, the lab we're going to do today is already online. We can pull and just we can code along. Good. I'm going to start coding right now. So if I do docker ps, system is logging. right? So all the image dockers are all the containers are now running. We have the Kafka, Zookeeper, and Redis. So let's start our integration, guys. So now for Node.js ecosystem, to use Kafka in your system, your project, we need to download, install a package. The package, we call it, um, if we come to npm, we're going to see it's Kafka JS, the most popular npm package in Node.js and JavaScript ecosystem. So if we come to, right, so this is it. How do we install it? Just npm install Kafka JS, and that's all we need. It's written in TypeScript, so we don't need to install types. So the types, it already comes with types. So let's install, do npm install Kafka JS. I'll wait for it to install. Then while it is installing, guys, we're going to create a module. Now this is how we're going to test Kafka, how we're going to integrate it to our system. Hello guys, hope you can still hear me. Hope I'm still, let me see if I'm still,
Yes, we can still hear you.
all right. You can still see me, right? You can still see the screen,
Yes.
right? All right, good. So now how we're going to demonstrate Kafka integration into our system is that we're going to create a news feed. News, this is a blog, this is a blog project, a blog website, for example, a blog application. So we're going to create news, like we want to integrate news. Maybe we need, maybe somebody, a news agency asks us to give them an endpoint that they can be sending news into our system, news feed, so that users that comes to our blog, they can also view news feeds on our system, and they can send like 1,000 news updates, at a go. All right. So when you have something like that, this is just an example, top of my head. So when you have something like that, somebody asks you to give them an API that can send large volume of data to, call large volume of data. What do? If you give them normal API that you create, it's going to lag your system. It's going to, so you have to think of way to create an optimal API to give to them to use, to call. So basically, that's what we're going to do now. We're going to create a news module, give them, create endpoint to create bulk, they call it create bulk endpoints that they can send bulk data. Then we create the endpoint to read those data, array of those data they send, those news feed they send. I also create another endpoint to read a particular a particular data, a particular news feed, right? So we're going to create a new module here. We're going to call it news, right? Then in the news, same thing, the way others are, we're going to create controllers, DTOs layer. We're going to create DTOs. We're not going to, yeah, we're going to create entities, routes, and services. Yeah, basically everything. So let's create controllers folder, create services folder, create routes, create entities. Then we'll create DTOs. So we are good. So here I'll create news dot entity dot ts. Here we create news dot controller dot ts. Here the same thing, news dot dto dot ts. Here routes, news.routes.cs, then news service.cs. Yeah, so yeah, so let's start with entities, right? Let me see what I have here. Okay, so now before we continue, let's come here. Hello, let's come here now. Let's create a config for our Kafka, right? Configuration of connection, how to connect to our Kafka. So basically, I will create kafka.config.ts, right? So let's configure our Kafka, right? Because yes, our yeah, the package we try to install is installed. So we have Kafka JS in our application right now. So let's do our configuration. So going to import Kafka JS, Kafka from Kafka JS, right? Um, going to initialize call it Kafka new Kafka. So it's going to take an object. In the object, we're going to have things like brokers. Brokers will take array of, we're going to come to that. Then we have client ID. Going to take a string. Now, what is broker? Um, Now, broker is the like the engine, the engine that let me call it the engine of Kafka, right? Is where where the data, the queues, and everything is being managed, right? When the consumers want to get a data, when the producers want to or push a data to Kafka, they push it to the broker. When the consumers want to collect data to process, they collect from the from the broker, right? So it's basically the Kafka engine that we're connecting to. And now let's have a look at our Kafka here. Kafka, if you come to the port map, if we do ps docker ps, if you look here, well, this is Kafka and it is running on port. What's the port mapping? It's running on ports. This is the port mapping TCP, right? So this here is the host machine ports. Why this is the container port, right? So we are going to connect, localhost at these ports, right? Because if you check here, if you check here also, this is the mapping here. This is where the port mapping comes from. So we're going to connect localhost at these ports here. So if we come here, we're going to do localhost because if we are running it locally, then the ports, right? If we have another port mapping, another Docker service that is running on another ports, we'll add it. So as you can see, it's an array. It's an array. You can add another port. You can add another connection, but it's still the same thing. It's just one I have here. So that is that. Then this client ID can give it any. Let me call it news data, right? So with this, we are now connected to our Kafka. We can use it to do whatever, create topics and push items to the broker and everything. So we're going to do that in our provider file. So basically what we're going to do now is export it. So we're going to do export defaults Kafka, right? Now remember I told you guys topic. We have topic is where you want to, is where you push your data to, like the group where you push your data to. because everything needs to be organized in the system, the Kafka system. So we're going to create a topic. Since we are processing, we are dealing with news, news. We're going to create a topic, call it something related to news, right? If it's another item we want to be processing with Kafka, we can just create a topic and give it another name, another name similar to that, so that we can easily recognize it. So I'm going to create export only Kafka underscore topic. Let me give it news ingest, right? Any name you like, it's your choice. Then we're going to be, there's what we call group ID, like consumers, like they work with like group ID. If you come to this diagram, let me see if it's here. Yeah, consumer group, like here. So consumers have like group ID. So when you are creating your consumers, you just connect them to a group, put them in a group so that they can probably work together. So if you come to these definitions here, I think I will share this link. Yeah, topics, this is where a stream of message belonging to a particular category is called a topic. Data is stored in topics. Yeah, partition topics may have many partitions, so it can handle an arbitrary amount of data, right? So partition offsets, there's some other things we can look at. Brokers are the system, a simple system responsible for maintaining published data. Each broker may have 0 or more partitions per topic. So cluster have more than one broker. um, Kafkas having more than one broker are called, Kafka cluster. So basically, guys, producers are the publisher of messages to one or more Kafka topics. Consumers read data from brokers. So guys, I'm going to share. Let me share us this. So, but we're going to see everything in real practice. We're going to see everything. This Kafka, this let me drop this here. Okay, you can just have a read. All right, let's continue. So this is the topic. So let's just create a group for the for our consumers. So I'll call it Kafka group ID. I'm going to call it news consumer group. Okay, so all this we can create. If you don't want to add, you can create an environmental variable for them. Let me even do that here. Let's create and call it Kafka ready. Kafka. Let's see. Then you can do this for also the for the brokers. You can also do client ID. So do client ID information. So you just to add these things here. Client ID. So okay, so we are good with this. You can bring them in here. If we just decide to say okay, let's topic. We'll have it here, or if we don't have it, use this default value. So I think the same thing also here. Client ID, right? On topic. So what I was saying, if we don't have it in the env, use the default value. So now let's come to our providers, right? Our providers, we're going to create a service, ready, Kafka. So guys, basically this is what I'm doing. I've created a configuration, a connection configuration, to help us connect to Kafka, right? So this is where this providers folder, this is where I'll now integrate all the functions I'm going to use to send data to Kafka from this our module, right? This our news module that's going to use this Kafka configuration, this Kafka setup, right? So if I create all the functions here now, then I'll come to start implementing news module. Then I'll start calling the method functions I'm going to create in this Kafka provider setup. I'm going to be using them in this news module, right? So let's come here to let's look at the configuration, the provider setup. So we're going to create here we're going to create entities. I don't want to make things too verbose, so I'm going to create entity, and this entity is like going to model what we're going to normally I'm supposed to I'm supposed to keep these entities here. Yeah, I think I should do that, right? Let me put entities here. So in the news, I'm going to do interface extend. Now we're going to extend just like the way we check for example comments, for example comment the entities here. We extended raw data packet from MySQL, right? So we're going to do that so that it can TypeScript can properly not here that TypeScript can properly identify, not complain, our entity. So we're going to give it ID optional number. Title is how our data is going to look on the database. Content, then publisher, what again, created at, yes, it's going to be optional. Date, updated at, going to be optional also, right? So is there. Then let's create DTO, right? um, how did I name this? My DTO, sorry guys, let me confirm this. Okay,
So, Christian, can you hear me? Please excuse me.
yeah.
Yes, so I need some clarification. This is actually my first class following you live. So
Okay.
I just want to, why are we using class for details, right, and interface for entities? Yes, I want to know your reason.
Okay, actually, it's just design. There's no actually technical reason, right? I can actually use interface for DTO. right?
All right.
Yeah, the main reason why I choose to design it this way is that in next when we go to next.js, our DTOs are going to be defined with class.
Okay.
Yeah, so it's in that class we do we validate, we would validate our DTOs, our data validation. We're actually be doing it in the DTO class. So that's why I decided to use class, so that we just get familiar with it.
All right. Thank you.
Yeah, you're welcome. So this is going to complain, so we'll just put exclamation here and publisher. So our DTO is good. Now let's go back to our provider and start creating. Now we need to create producers, news producer class, and we'll create news consumer class, because we need to produce like the producer and the consumer, right? So we need to create a function to produce data into our Kafka, then have the functions to process. That's consumer, right? To consume the data. So we're going to create something like export class news producer. I will have news consumer class, right? So let's start with the producer here. But first, let's import our news entity and DTOs and the rest. Oracle. I didn't export news entity. Import it manually. I don't know why it's all right. So now let's start our defining functions in our. So we're going to define various kind of functions. First, going to do something like this. Create a static, yeah, private static representation of our instance. Going to be the same class. So we'll give create a private instance of our producer to I don't like how I instantiated this thing here. I'll have to look at it again. Then we'll create something to tell us if Kafka is connected. We're going to do some kind of serious because serious connection configuration, right? There are some codes we are not going to like directly write functions to produce and functions to consume. We're going to add some other functionalities, and the reason is that when we start our application, the how we're going to run Kafka and Kafka engines and our application is that when we start our application needs to connect to Kafka, right? So it needs to know if Kafka is up, is connected, and it's going to wait for Kafka. Wait for Kafka. If Kafka is not started, it will wait. If Kafka is not started, it will wait, and it will just be pinging. Trying to see if Kafka has started, and if it has started, it will not connect, right? So that's one of some of the functions we're going to be creating here to check, to do those checks, to wait and connect and everything. Then also we're going to be writing some functions that will tell us, okay, producer, we don't want to be creating producer instances every time we want to connect to Kafka. We want to send something to Kafka, so we're going to, when we want to get a producer instance, we need to see if we already have. If we already have, we'll use the one we have, but if we don't have, we'll create another one, right? So that's why you're seeing these items here: instance, producer, and is connected, right? So let me just put a constructor here that does nothing. We can still omit it. So let me see if I still have. So we're going to create a static method called get instance, right? So this is the thing here, to get instance of. So help us see if we have, if this instance, if we have an instance, return okay, let me see if we don't have it. If we don't have it, it means we need to instantiate news producer. Going to create our instance, then return, right? So this is it, to get instance, like to get the instance of our producer class, Kafka producer class. Then if that is done, we need to connect, right? Whenever we when our consumers and um, producers starts up, we need to connect to the Kafka broker, right? So we're going to write a, that's where the logic is. When the Kafka, our application, wants to connect via the Kafka configuration, it's, have to be poking, to wait and wait, to see when it's finally started before it can connect. So we're going to write a function connect. It's going to be void, return promise of void. It's promise because it's async. If anytime you use async, you must wrap the return data in promise. So now let me look at this, guys. Please, as you are following along, if you are not, if you have any question, just call my attention and ask. Then we need to see if we are connected. This is connected. If we are connected, we return. Let's don't need to connect again. If we are connected, then we need to retry. Give it 5. Okay, here. Then retries. Retry is still greater than try and cache. So this is the connection, the logic I talked about. Need to check. We need to check if need to be checking to connect. So need to be checking poking. Then so this is how we do connect. We do now, guys. Where do we get this producer from? If you check this variable producer here that I am calling here to connect, right? This item here I'm calling here to connect is actually from this Kafka configuration connection here, right? It's actually from this Kafka producer here, from this connection. Let's go back and have a look again. So this is the connection. Yeah, this is the here. I'm just what I did there was just like call Kafka producer. Right, you can do this. It has properties of producer function that you can call. The same thing also for consumer, right? You can see the other field here. You can see admin, logger, producer. So these are the properties that you can call. There's admin, there's consumer, there's logger, there's producer, right? So basically these are the items you can call on this Kafka configuration, right? So basically that's what I did here. I called the producer path, right? In the consumer, I'm going to call consumer, right? When I want to consume from consume data that have been produced, right? So if the condition is successful, right, I will now update is connected to true, right? Well, if connection is let me console log to say that's Kafka producer connected successfully, right? So but if this connection did not work, it's going to throw an error here. That's why we have this try and cache, right? So I'm going to cache it here, cache the error here, then I will retry again. Then before I will try, I will reduce my retry count, then retry again. Then let me console log to notify um, let me know what is going on. Connection. So guys, this is basically this setup here. This setup I'm writing here, when we transfer convert everything to Nest.js, right? Nest.js have a kind of configurations that we don't need all this logic that I'm writing, right? There's a way Nest.js will do it in Nest.js that Nest.js will help us to handle all this wahala we are doing here. So if retries, we have to check whether we have exhausted our retriers. If we've exhausted retry, it means that something is wrong with our Kafka, that will rethrow the error. But if it is not, we need to try again. Await new promise, then set timeout. So what we're doing is we have to wait before retrying. Wait 3 seconds. Wait 3 seconds before we retry again, right? That's basically what that last line is doing. So if there's an error, this is it here, we want to do 5 retrials, right? But before we want to connect, we check if we are already connected. If we are not connected, then we'll come here, we want to try 5 times. We want to do 5 retrials of connection. Then our while loop will start. We check if we are still trying retrials, yes. Then in try and cache, it will first, if it will try to connect. If we successfully connect, our variable is connected will be updated. Then we'll console log the success message. But if this connection here fails, it's going to throw an error, which we're going to cache in this cache block of the try and cache. Then when we do that, we'll have to reduce our counts of trials. Then we'll console log tell us that we are not successful. Then here we'll check if we have adjusted our retrials counts. If we have, we'll have to throw the error now, because if we try to connect 5 times and Kafka is not connected, it means that something is wrong with the Kafka server or engine. Then when that is done, when we have not exhausted our trials, then we'll have to check again. Here we'll have to wait for like 3 seconds. Then if we wait 3 seconds, then we'll come again and try the whole logic again from the beginning here. Then if we finally connect, we have to return. Sorry, I forgot this return here. Finally connect, we have to return from the function, right? So that is for connection. So here we have settled connection here. This is just to help a helper function, not the real deal. Then let me put the disconnect, because actually you need to disconnect your app from, but it's not same thing here, void. So check first, are we connected? Is connected. If we are connected, then do await this producer, because we're working with producer, disconnect, right? Then set this is connected to. So this is simple. Now guys, let's do a proper logic here. Now let's write the logic to send our message, our data to Kafka. All these functions here are just to connect and disconnect from to Kafka broker, right? But now let's write the main function to send our data to Kafka broker, right? Because this is the producer class here. So we're going to call it async send news batch, because we're sending a batch volume, right? So now now what we're going to do, we'll accept news, like the data we're going to use. The type is news, is type of news DTO array, right? We're going to bash it, right? So they want to send 100,000 of like let's say 200,000 data, right? 200,000 array of data, size of data, right? So when they send it, we don't want our system to start process everything at once. To optimize Kafka and everything, we need to bash it, like, let Kafka process everything batch by batch, right? So to do that, to give specify a batch size, we'll give it a default of 1000. Can use any value you like. Let's put a return. Let me leave the return for now to give us error. Then now we have received it. First, what do we do first? We need to check if we are connected, right? If this instance is connected, do this is connected, right? We need to, if we are not connected, we need to connect. We'll do await disconnect, right? Yes, we're calling this function here. This function here is what we called here connect. That's the logic to connect to. When we call it, it execute all this logic here. Then if it's connected, finally I will proceed to process. Now I'm going to specify current batch. It's going to be an instance of news DTO also array, the same as received. Then when we have this, we're going to, because we want to keep tab, like if they send the data to us, for example, if they send the data to us, it's not everything we're going to store our database. We need to clean it, data cleaning, right? The value, if let's say among the data there's the content is empty, you're going to remove anyone that has content. There's no content, because you don't want to populate dirty data in your system, right? Anyone that has no um, content, you remove them. Anyone that has no title, you remove them. Anyone that has no publisher name, you remove them, because those are the things you want to show on your blog, on our blog. So if any one of them that doesn't have that, you have to remove them. So you have to clean it. So when they send out like 50,000 data and we clean like 1,000 or 100, we want to let them know that okay, 500 is not published, because we did not publish 100, we publish the remaining amount, right? So we're going to keep track of that here. So let's we're going to define values for that. Publish is this, discarded is this, right? So this is to keep track of that. Then when we start processing, we'll update these values. So I'm going to create another function here, call it send bash. It's different from the main function. The main function is send news bash, but this one is going to call send bash, and it's going to be an arrow function. What's the time now? Okay guys, when it's 2:30, like when it's in 3 minutes time, in 7 minutes time, we're going to take a breather, right? So that we can have a rest and come back like 15 minutes time, right? Please, let's do that. But before that, let's continue. Then so now this function here, we're going to, why I want to write out this function is that down below we're going to do some processing. That's when we finish the processing, then we'll call this function here to actually do the sending, right? So because we're going to do some processing down below, when we finish the processing, we'll now call this function to do the actual sending of the data, right? So let me come down here and implement the processing. So before I implement that function, so here I want to loop through the data. Now I'll use this method item of news. Now news is the data we are receiving, right? Is the amount of data we received. So I want to loop through each of them now, right? So to loop through, like I said, we're going to sanitize them, check them if they are valid or not. So that's what one of the things I'm going to be doing here. Then if it is valid, I will add it here. If it's not valid, I will not add it here, right? So how do I check if it is valid? For that, I'm going to create a small function here. I'll call it is valid news. Let me see. All right, basically I want to, let's create it outside of our function of our class. Let's not populate so let me create this, let's create this one function is valid news. Well, actually I should have written this. I'll change this, most of this. Okay, so if I receive, so I'll need to check news is length greater than 0, like is it not empty? Okay, if it is, then I'll check the content, and I'll check the publisher, right? If they are not empty, if any of them is, if all of them are not empty, then we know that they are valid. Then I'm going to write this get valid news. I'm going to receive items of like DTO array, return the same type. what it's going to do, it's going to do some data filtering, and want to filter individually now using. So guys, this is it. So I created two functions. This one is to check if a particular one, just one data information, one news information is valid. That's if the title, the content, and the publishers are not empty. None of them is empty. Then I created this one that this function to get arrays of data item. Then it processes each of them using this logic here, this function here. Then it only returns the ones that are valid, right? So why, when that is done, we'll need to use it here now. This is where we use it. So if I, okay, so basically I think we're using, so if I want to loop each of the item now, we'll do if is valid news, check if it is not valid, right? That means it's a discarded item. We need to discard it. Like we need to forget about, we don't need to use it. We don't need to add it to our batch. That's why we use continue here. But if it is valid, we need to add it to current batch, right? Now if we have added that we have added to our current batch here, now if we have added, we'll keep track now if our current batch, the length, right, if the length is equal to our batch size, right, this batch size here, this batch size, right, if we have accumulated enough of this batch size, right, we need to send it, right? That's where we call this function, send it. So this is the function that does the actual sending, right, the actual sending of our data to Kafka, right? So what's the function is empty. Let's see. So guys, this is 30 minutes. It's already 2:30 here in Nigeria. Let's take a breather. We'll come back to 45. Then we'll implement this function. Then when we finish that, we'll now look at the consumer. Then when that is done, we'll now move into now go into the modules. We'll now create the modules and tests, right? So let's come back in the next 15 minutes, right? Thank you guys. Pause this. Hello guys, welcome back from the break. Let's continue. All right, let me see if I'm sharing my screen. Entire screen share. All right, so let's continue. See what I'm sharing. All right, so basically I'm going to implement the send function, right? So this is a function that actually do the actual sending of our data to Kafka broker. So let's implement the function. So all right, so here current batch, before first check if we have anything or not in the current batch. If we don't have, we just return as if it's zero. But if we have, we'll now do the proper sending. We'll call Kafka to dot producer method object, Kafka object. Then we'll call the send method on it, send function. Then we'll give it the items to send. Now first thing we'll define is the topic, right? Topic of the item we want to the topic that we're going to send to, Kafka topic that we defined in the config here, import it, and I specify the messages, right, as what we're going to send. Right, it's going to be an array of objects, and the object is going to have value. Right, now we're going to send the value is going to be a string. Right, so what are we even sending? We're sending this current bash data here. We're sending this data, right? So but it's an object, it's an array of objects, so we need to stringify it by using the JSON stringify objects, then call it this way. So we are good. Then let me put this here, compression of 1, just to compress the data for proper, for optimize delivery. Then when this is done, we're going to update our published data as the amount that we've published. Going to add current batch, that's the amount we've already published. Then when that is done, we're going to reinitialize current batch so that we can start again. Right, so that's the flow here. So basically let's reiterate the function here. We started here to, if you want to call this function, first check if we are connected. Right, if we are not connected, we have to connect to the broker, right, to the Kafka broker. Then when we have connected, we need to keep track of 3 items here. First with the current batch, because we're going to process the chunk of data batch by batch, and here we specify a batch of and a batch parameter, and the default is 1000. You can specify any amounts you want. Then when that is done, we specify we also want to keep tab of the published items we've published. Then the next one is the items we've discarded, like we didn't publish. Then here we define the function that actually do the main sending of those data to the Kafka broker. Then before we go here, let's look at this here. Then here we are looping through each of the items, like each of the items. So items of news, news is the data that is being passed here, the parameter here to the function. Then we are looping through each of the items. Then we are using this function to check if that particular item is valid, like the title, the content, and the author values are there, because that's what is valid news does. If we go here, this is what it does. It checks, right? We run ants on them, the length, that if it is true, if all have if all has content, we send true. If it's not, we send false. So that's what this is doing. So it's return either true or false. If it is false, that means we discard that content. We just continue. That we operate, we increment discarded count by 1. Then, but if it is valid, that means we have to put it in the current batch, right? Push it into the current batch array. Then if we now check, is the current batch that we have now, is it up to the batch size that we have, that we want, like the batch size we want to be processed? If it is true, we'll now call the send function to do the proper sending, right? So let's look at this send batch, what it actually do. So if we come here, the send batch, what it do is it first check the current batch, because that's actually what it's using, it needs to work on. If the length is 0, that's if it's empty, we just continue, just return. We don't need to do anything. But if it is not empty, then we need to now do the proper sending. Now call the send method of the proper object, of the producer object of Kafka. Then what does it need? Topic, messages that we need to send. This is the message that we stringify this array of data, right? This is how you set up everything. Then when we send it successfully, we'll now update the published, that's amount, the data of published, update it with the current batch amount. Then we initialize current batch to empty array back. Then this is it, guys. When you finish this, our producer class is now ready, right? So we need to have return some this information here. Okay, so let me do this here. What are we returning? Let's return. Let me define the type here. So we'll be sending total object. Total will be number. Published will be number. Discarded will also be number. So when that is done, we'll now come to the end of the bottom part of the function method and do our return. So total will be the total we received, which is the news content. Then publish will be the same thing. Discarded will be the same. Okay, you cannot find. Did they mean? Oh, published. Expect published wrong. Okay. Right. So we're good. So we return it. So we are good with our function. So we creating the um, consumer class here, the news consumer, right? So now first thing, private, let's initialize our consumer just like we did um, for the producer here. So call this. Then consumers takes the group here, like the group ID where you want to the group you want to assign them. So this is where we use the group ID. Then now check, is it connected? We need to be keeping tab if we are connected, because it's very important to know if we are connected. Then we create a function to connect, because it's a big deal for us here to connect to our so we want to connect to our Kafka broker. So let me see, let me put on my ring light. Let's see why this is not. All right, guys. Now let's implement our connection. So first check. Use this is connected. If you are not connected, then we need. If we are connected, right here, we need to see if we are connected. If we are connected, no need to try connecting again. But if we are not connected, it's just the same retries. The same logic with the one in producer class. Then let's try cache. Try and cache. Then here in the cache, in the try, let's try to connect this consumer dots connect. Right. So if we are successful, will now update to true that we are successful. Let me see if, okay, true, we're successful. Now say okay, Kafka consumer connected successfully, right? Then we'll have to return as if we're connected. But if there's an issue, then the same logic here that we implemented in after the user accounts. Let's tell console log that consumer connection attempt failed, retries left. Alright, so we are telling now notifying us that connection did not go through. Then here, if we don't have, we have like, if we exhausted our connection retriers, means something is actually wrong with our Kafka broker. Then we have to throw a proper error. We have to throw the error because something is actually wrong. But if nothing is wrong, we have to wait. You have to wait, set timeout, then wait for like 3 seconds, then we'll try again. So basically this is almost the same logic. This is the same logic with the producer one. Then when this is done, we need to actually, consumers actually, when you start your applications, consumers, we need to start like immediately your server start running, consumers should also start running, right? Because they need to be active so that when data comes into the broker, they will just execute the data, they will process the data immediately, right? So that's basically we're going to, that's the logic there. It's not like, they are not like producers that when you want to use them you connect, right? When you want to use them, you when you want to call when you call a producer, it will connect first to the broker, then execute. Then after executing, it can just disconnect, right? But brokers of consumers connect and starts running in the background like a background job, so that when a job comes into the broker, they execute it immediately, right? If you look at our send function here, it tries to connect, then execute, right? Here, see, now we just created in the producer, in the consumers, no, in the producer, we just have the send news batch here, which what we call it, it first try to connect. If it's not connected, it connects. If it's connected, it goes ahead to process and send the batch to the Kafka broker. But if in the news consumer here, we don't have a send, anything send, what we have now is going to be, we already have connection logic to connect. Then we're going to have it create a start function here. So it's going to be, well, when we start our application, we call the start function, which is going to start the consumer to start looking for, starts waiting for jobs to process. So here, to start to first connect, calling the connect function we created. Then when it connects, it subscribes, right? The consumer subscribe to the topic, right? Needs to subscribe to that topic. So when it subscribes to that topic, then when the producer sends to that topic, it executes it, it produces, it processes the topic here. right? Because if you check here, if you check our news producer here in the send method, in the send here, we look down here in the proper sending function here, it sends to a particular topic. Yeah, this is the topic it sends to, and the message, the data it sends to. So the consumer, we have to connect, we have to subscribe to that topic, right, and start working on data that comes into that topic. Then we're going to add another thing here from beginning first. Then when this is done, let's notify in the log here, in the app log, news consumer started and listening for messages. This is our, so that we know that everything is fine. Then let's implement the logic to run. After subscribing, now need to call the run method so that when message comes, it executes. Then takes, have each, on each message you're going to use each message, they're going to define functions here that is going to execute when we have a message, right? On each message this function is going to run, right? So the function is going to, we're going to give it takes message as argument. Then the message is the actual message we want to process, the message that has been sent. That's basically this message here. So let's go to the producer, this message here, yeah, this message, each of the message data to be sent here, be sent from this function here. So we come here, recording here. So now say if I check whether there's value, if there's no value, if there's nothing to process, we return easily, silently. Then but if there is, we have to do try and cache, right? So let's define what we'll do in this try and cache. First let's get the item. Okay, items, news entity of type, then message dot value dot to string. To string, right? So we want to pass. So here actually when we are sending the message, from the producer, the type is actually let's go back and see, it's actually the DTO type. Yeah, news item DTO arrays, that's what each item is. The type is DTO news item DTO. But here in the consumer we are typing it, we are type in it to news item. Basically the two are the same, the news item, the news entity, and the news DTO item DTO, they are the same the way I define them. But in your case, if the two of them are the same, you don't need to, you need to properly typecast everything well, so that you have issues. Maybe just where if the DTOs and the entity are not the same type, like they are not, don't have the title, the same title string, content string as author string as I have in the two entities, the two news entity and the DTO. If they are not, on your own case, you have to properly do the typing, properly convert from this data from the DTO to the entity, right? I hope that is clear. All right. So Now do some proper check to see to know to validate our data is, sorry, this I need to check if the data I received is an array items, then at the same time, or if the length, if it's empty. So if the data I receive is not an array and or it is empty, I will just return silently. Then but if everything is okay, do I want it, we now need to proceed to process the data, right? So our chunk size here is 1000. I want to use chunk size. So remember, everything is bash. We want to bash everything. So here I will do I will loop through. Let's loop through each of the items here. So looping by chunk size. Then get a chunk of the data, those slice. So we want to, like, we are chunking the data. Let's say we send 5,000 for example, and we want to chunk it by 1,000. We want to process like measure by 1,000. So this is inside the Kafka worker now, right? Inside the Kafka process that is working back at the background, right? So if we send, let's say here, for example, here, if we use 5,000 here, for example, if we use 5,000 here, if I change this to 5,000 for example, and we send 5,000, we are sending 5,000 of the bash, of the whole data volume, sending 5,000 each. And in the consumer here, when we receive 5,000 and we want to process, we'll process, let's say we are doing chunk size of 1,000. You see the difference? So it means for each 5,000 we send, for each 5,000 the producer sends to the broker, the consumer will chunk it by 1,000 to process. That's basically what we're doing here. Chunk it by 1,000 and start processing it, right? The producer will send 5,000. The consumer will chunk that 5,000 to 1,000 and process, right? Basically that's what this method, that's what we're doing here right now. So process, so the chunk of 1,000, what do we do with it? We have to, because just here now we can do can run any kind of process on the data, right? But basically what we're doing is just to take it, do some cleaning and store to our database, right? So we're going to do, bring out the information, publisher, right? So we want to just put everything in an array, just for us to properly use it in our MySQL query, right? So here I have gotten my values. Let me write SQL query. I'm going to do insert into news. The columns are title, content, publisher, right? And the values will be, let me bring this to the next slide. The values will be these values here. map. Okay, going to just do some manipulations here. We need to use type binding, param binding. Yeah. So just convert everything here, make it join. So this is just to properly format the data so that we'll properly insert it into our query. So now we need to like flat in the arrays here. This is just arrays manipulation. Alright, so values dot flat. Then we are now good. So call our weight pool dot query. Call our pool query here, and flat values. So our pool is not imported. We need to import it from our database. Right, that's where we got our pool from our data config. So from our database connection. So when this is done, yeah, so we have processed our data, right? So in this logic here, this is where you can call, there's what we call extracts transform load, ETL, extract transform load, right? It's a concept in there's what we call software for data analytics, right? Software for data analytics. So it's concept whereby you write an application that extract data from a source, extract data from a source, transform the data. Transforming the data means either cleaning the data, like filtering out any data that does not have any value you want, that's cleaning the data, or you enrich the data in the sense that when you've gotten the data, you to transform it, you enrich it, like you fetch some other data from other APIs and update, add it to the data that you have. That's transform. Then you loading is like you store it in your database or somewhere in a storage, right? That is ETL, extract transform load. This concept is peculiar, is very common in software engineering for data analytics, where you are, as a software engineer, you are required to build that kind of system that will extract, transform, and load. And these data are in streams, like they come in stream, like real time as they happen. You extract, you as they happen, you need to write an API that process these data in stream or in batch. They come in high volume, then you process it. So basically, this is the kind of setup you need to use to do that. And in that concept scenario, now if I'm to perform an ETL process on this API that we are implementing, right? If we want our Kafka to do perform an ETL process, this is where I'm going to implement that logic right now, right? So before I store it on my database, I will have to call some external API here. I will call some external API to do one or two things, to maybe fetch an API, use the ID or the title to get an API populated here. Maybe the author, maybe if we have the author, where we can fetch author, more of the information from the author, we can just call the API, fetch the information of the author, and add it to whatever we have here, right? So if that kind of scenario, so this is where you just implement that kind of logic, call some external APIs and use it here, and run your process, right? So but here we are not simulating something like, just here we're just taking it, filtering and storing on our database, right? So let's go ahead. So we just store the data here, or we store data on the database, and we are good to go. So when this is done, I will just console log process. So I want to tell log out the number of items I have processed. So this is it. This logic is complete. Let's just, if we have any error, just, so here there is something I should have implemented here. Instead of console logging the error here, there's what we call the dead queue. Dead queue topic. Like you can create a separate topic, maybe if you want to keep tab of the data that are problematic, right, that didn't allow you to get to, that didn't get processed, right. This is where, in this error place, in this error login here that I'm doing here, I will just call another, I will use a producer, another producer. I will use the producer and call and send this data to another topic. Maybe I'll have a topic. I will create a topic. I'll just create the topic, then I will just do something like this. I'll just call use the producer. In this consumer here, I will also have a producer. Maybe I will create a producer instance, right. In this consumer class, I'll create a producer instance, right. That whenever we have a bad job here, I will use the producer and send that job to another topic. And that topic, what it does is that I will implement it. I'll do a check here. I'll implement the same thing here. That's like I will do a check here. I think I'm going to demonstrate that. Then when I send here, if I use the producer, send that bad job to that topic. Maybe I may call the topic bad news or unprocessable news, right. Then if I call that topic and I send the message to that topic, right, then when I send it in this same logic, because the topic is going to come here, it's going to come to the consumer, right. It's still going to come to this consumer, but you need to implement a logic to detect that topic, that okay, this is the topic, this is the particular topic. It means I will have two topic, the Kafka topic that we have, this topic that we have, and the other dead bad news topic, right. So when I send when right, okay, when the consumer, when we maybe we have a different a consumer also subscribe to that topic, so that when the job comes in as into to be processed by another consumer, right, the consumer will just send it to, we implement the logic to just send it to, maybe store it in a database. Maybe we want to store it somewhere, right, to, so that later we'll have a look and see all the news information that are not processed. So what that topic will just do, what that consumer will just do when he receives that topic of bad news or unprocessed news, to just send it to the database, right. Just send to it. It won't process it, just store it in that database so that we can have a look later. So this is where, like, this area here is where you're going to implement that logic to send, right. But I didn't implement it. I just want to console log the Kafka here, the error message here, right. So guys, this is the logic to process a job. I think we are good. Let me implement the logic to disconnect a consumer. Then when that is done, we are good. We're good to go. I don't know if I am clear on that. This unprocessed news item. Disconnected. We have to disconnect consumer. Disconnect. Let's see, it's connected to sets. It's connected to false. So guys, we are good to go. So there's one thing I need to do here. Instead of exporting the class, the news consumer, just the news consumer class. Instead of exporting it, I will export it as an initialized object. Export, call it news consumer. So here, why I did this is just because I need to immediately call the start function when I import it in another file. Just style, just style how you want to implement. Then guys, so we are done here. Kafka is ready to be integrated into any module that we want right now. Kafka is ready to be integrated, right? So let's come to our news module, right? Let's come to our news module and start our integration now. So basically what we've been is just integrating, preparing Kafka to be used, right? So Kafka is ready on our system. Let's just start our implementation. So let's go back to our news module. What do we need to do here? First, let's create the services, right? Let's create the services. Here we have the entity. Good. So let's create the service class. Going to have class news. So what are we going to do? What are the methods we need to do? So first of all, our dependencies here. We need to get our Kafka producer, right? We need to import Kafka producer to produce, because this is where we produce the methods, the news, the data we need to send. Right, so I also need the database configuration. So that is done. So now let's create our function that helps us now to use Docker to process that, to process the large volume of data. We're going to call this ingest news bulk, right? So it's going to return a promise, like nothing, not going to return anything actually. So it's going to take data, and the data is going to be the same DTO as we've used before in our Kafka. Then okay, let's make it return. Is we need to let's return the number of items we received, which is going to be number, published number, and discarded type number, right? So let it be there, let it be there. Then let's continue. So first check if data is empty, like the length is 0. If data is empty, let's just return like if data is empty, we just return. Hello guys, please give me a minute. All right, so let's go ahead and so if we have data actually, so what do we do now? We now call our producer, right? To send to send a message. Do await. Call this producer, right? Now send call the message the our send this batch, right? Oh, sorry. Then what do we do to it? We send it our data. Right, we can specify the batch, right? But we have a default size. We have a default batch size of 5,000, right? So let's use it. But we can send it. You can give it if you want 10,000. If you want 10,000, you can use 10,000. But let's leave it as 5,000 here. Then we will need to because this function return this method returns data, have a return value like the number of it has processed and the number it discarded, right? So we need that information too. So I'm going to destructure it. I'm going to destructure it here. So we have total, we have published, and we have discarded, right? So we need to send that information to from here. Then call receive is the total here, like the one we received. Then we have published, we have discarded. So we are good. So this is a service method that will help us to process that large volume of data, right? So let's there are other methods on the service like to get. Let me implement to get, because when we send data we want to I would like us to see it immediately also. So let me implement the method to get, to fetch the item whatever we send. So it's going to be paginated, so we're going to take right. Pagination is one of the ways to optimize your reads, because you don't want your query to to fetch everything from your database at once. So you need to paginate it using their page limits and the rest. So here, let's just do calculate the offset we're going to use. It's going to be page minus times limits. So now let's write our query. Query to fetch. Here, if you see here, we didn't write any query. We just use send it to Kafka here. Normally we're supposed to write query to, but we're supposed to write SQL query to send. But it's Kafka that we're using to send to update, to write to our database. So we're going to, that's why we use Kafka here. Then let's continue. I want to fetch, right? Select ID, title, basically everything. Publisher, created at, updated at. I use asterisk if you want. Let me come down here. From news, order by, let's order it by created and the ID in descending orders, both of them. Then the limits, this offsets this, right? That is the pagination logic. And when this is done, put the values of sets and limits, right? So this limit will be here, this offsets will be here. This is parameter binding. Yeah. So when this is done, we are fetching. So with the structure, the rows we're going to get, yeah, whatever we got here, we're going to get here is 0, right? So I'll wait. Okay, I don't know why I'm getting this message. Type query must have that returns an iterator. This pool. Okay. Okay, query. Let me continue here. Use rows as let me see. It extends it. Why is this? Must have an iterator. I think I've gotten this error message before now. Let me see. I'll check this out. Don't know why I'm seeing this message. Right, so then let's do a count rows. We want to like count the total number, so that you'll be able to like, it's proper for pagination also, so you know the total count we have on our database. The query is the select count as total from news table. Right, so when this is done, total, let's just type cast, make it any, and just do total. These are just to make TypeScript happy. Let me see. Oh, sorry. This is from promise. Import from promise, guys. Be careful. Whatever we are importing from MySQL 2 package, it's actually slash promise from the promise part of it, right? So that was the issue I was getting here. I know this error is something I have encountered before. So when we return the news that we fetched, right? So basically this is it. I'm supposed to return the total number, but let's leave it now. So this is the service. Let's implement the controller, right? The controller logic. So export class news controller all the time. What? Smooth 4. Alright. So let's implement controller. So here need we need what? We need the service, right? Your controllers only always need your service. Import it here. Then let's write our ingest news. So it's going to be async, don't forget, right? So it's going to take requests. Don't forget, our controllers always take requests, and the request type is we import it from express. So there's going to be response type. So there's going to be next function type. So right, this is response. Next one is next, which is going to be next function type. Right, so what do we do here? It's just basically the same thing we do with other controllers. So we just like, so in the logic here, I want to when in the body here, in the body, when, let me just demonstrate here in the okay, let me open Postman here. Right, in the, yeah, in the creates, like the endpoint, you're going to give the news agencies to send data to us. The endpoint is going to take this is how I want to send the data, right? This is the JSON body, right? So it's going to have a property of data, then the value will be arrays of objects, right? Just as you're seeing here. So this is how we're going to be sending data. So how we're going to receive it in the controller. So basically we're going to the structure out, or I can just do data rec body, as this body now is the whole JSON object here. Then I'm going to pick out this data here that I need. So dot data, by doing dot data, right? So I'll do as news item dtu array, because it's going to be array, because the data here, this is an array, right? So basically, and it's news item dtu array. So when I get it, if I'll check if it's not empty, like if it is empty, let me just tell to check. This is saying if it is empty. If it's empty, I will return a 400, no, error, saying with a message that invalid payload, invalid payload. Just message anything you want to write. Data must not be must be, let's say must be non empty array. Right, so I will send them the message. But if everything is good, like there's data, then I will use my service, call my service and call the ingest method and just give it the data to process. Yeah, ingest bulk and give it the data to process. Then the results will be the result. I'll send it to the front end to tell them that's okay. We have accepted news. We have accepted the data. So the data is being processed in the background, right? News data accepted for processing. Then maybe we'll now send them like how many we processed, the published, discarded, and the rest. That's what this will be. The If you check here, if you hover over it, you see received, published, and discarded, because yeah, that's what we're going to send to them. Then if there's any error, we call the next function and send it to the error handler, right? So this is the ingest logic. So let me write the logic to fetch, so that when we populate our database, when we send the data, we need to fetch to see, right? So let me quickly implement get news list. Let's return. It's supposed to return. Okay, no, let me just leave it. Right, so we'll accept the same thing here. Then we'll put it in try cache. Then here we'll come here, we'll get our page, page value, which we'll get from query dot page as string. It's going to be string data type. But we need to type it to number. Then we optional, if it's not sent, we use 1 as default value. Then limit, same thing, request query dot limit. If it's not sent, let's use 20, right? So let's call our service news service to get news, give it page and limits. Then whatever we get, we return JSON, right? Just return straight up. Then we call next error if there's any error. So this is it, guys. We've created our router. No, we created our service and our controller, right? So the next thing now is to create our router, then test. I know it's almost time, right? So what do we do in our router? First, we import our router object from Express, right? our router class from Express, and we'll create our router object with it, which is just by calling router. Then we are good. Then we need to create router dot post for the bulk. We're going to call a function here. Let me leave that for now. Then create for get, the one that will help us to fetch all whatever we're going to create, right? Then let's export default router, right? So it's configured. So now let's import our controller, because it's controller method that we're going to attach to our router, right? So let's do that. Right, how do I name it in this place? Sorry guys, let me confirm this. Okay, comment controller, should call it news controller. Then news controller. Now news controller takes what? It takes the news service as dependency. News service as dependency. Then we'll take it and give it, optionalize it and give it. Then news service takes two arguments, right? It takes news producer the news producer class, and it takes the new producer and the pool database connection, right? So let's call news producer, and rather let's just call it directly and use this method, the get instance method. Let me call it Kafka news producer, right? Then the other one is the pool connection pool of database connection. So we now have our configurations now set up. So now let's start mounting them to the router. So news controller, this one will take this, then news will take this. And don't forget our bind. In case, right? So guys, now let's we've created our route. Let's come to the main route here and wire it up. So basically we're going to import, call it news route. We to import it from the modules of news route. Yeah, so we're going to add it, call it news. So guys, we are good to go. Our service is ready. Our service is ready. But there's one thing now. We are set, so we need to when we start our application, we need to start route doc Kafka, right? So we need to start up Kafka, right? So to do that, let's come here, come to our server here. So there's one more function I need to implement. We call it wait for Kafka method, right? Let's It's just a utility method to help us wait when Kafka when we start up our applications, right? When I implement that function, we'll integrate it into the server and everything will be ready up and running. So let's just quickly implement that. I think I should this should be in the utility class, the utility file. So wait for Kafka is the name. I'm going to give it a parameter max retries. So basically we use it to wait for the application to know when the Kafka is being started, right? Let's give it a default value of 10. When the Kafka engine is started before we start connection. So it's two things here. We have to wait for Kafka brokers to start before we start trying to connect, right? Before we start pinging it for connection, trying to connect it, right? Connect to it before the brokers. I mean, before the brokers, our system will try connecting to the brokers. So let's use this here. We're going to do Kafka. Going to use this admin here, this admin function. So we're going to do a count loop because we want to do max. Um, we need to keep count of how many retries we are doing here. Max retries. Then here we'll try to connect. The admin will try to connect. Then see if our topics are ready. And at the same time also if they are ready, we just disconnect. So basically just try and connect. If we connect, check if topics are ready. If the topics are ready, then we are good to go. We just disconnect and we notify the system that you send that through that it's ready, right? So let me put a console log before Kafka is ready, right? So this is what we'll do then. But if there is an error, maybe we were not connecting, let me drop a message also, say waiting for Kafka to be ready. Just dropping fancy message. Sorry, no. Just keeping tab of the counts. Right, then when this is done, we'll have to try again by resolving the promise and waiting 3 seconds before retrying. So but at the end of everything, if nothing happens, we just return. After trying 10 times, if nothing happens, we just have to return false because something is wrong with Kafka definitely if that happens. So now let's go to our server because server is where we start our app. So we need to we configure it into configure Kafka into it also so that we'll be able to as the app starts, we'll also start Kafka. So this function here, this is where we'll start. This callback function is what is executed immediately our app starts. So this is the best place to execute, to implement this, to start up our Kafka. So we're going to use set timeouts, to execute after some time. So in this set timeout, we're going to, so this, what this set timeout is doing is that when Kafka starts, we're going to give it, when our app starts, it's going to wait 4 seconds before executing whatever we give it here. And what are we going to give it here? We're going to give it these functions to start Kafka. First, we have to wait for Kafka. We're going to call this waits for Kafka function. Right, call it. It's going to take a wait. Right, then we have to get if the value it returns is Kafka ready, which is either going to be true or false, right? So all right, so I'm still recording. So it's going to be true or false, or it's already false. Then we use it to check, so if Kafka is not ready, so we need to return, but we first drop error message so that we'll know in our system that Kafka failed to become ready. So consumer may not work properly. Yeah, because our Kafka is not starting. Right, so we need to return, because there's nothing to do again. But if Kafka connect is ready, then our producer will get our producer then we connect, right? Where the producer, we connect producer, then we get consumer and connect consumer too, right? Then we'll get consumer, we need to import consumer, like the class are instantiated, then we'll start consumer, right? Consumer is already connected, so we just start it. Right, let's go back to and see the start method of consumer here. So it's initialized. So in starting the consumer, we connect it, right? We connect it, then we subscribe, then we start, right? Then we call the run subscribe method. So it starts running in the background. That's basically why we call the start here. Then producer is just to connect producer, so that when query comes, we just send directly. Right, consumer will after starting, it will just be running in the background. Then after all this logic here, this try and catch if there's any fail operation, just log it in our system so that we will know. Say failed to initialize Kafka services, and this is the error. So guys, this is it. So this is the startup. Then let's just add one more thing here. We need to, if our system shuts down, we need to disconnect. We need to gracefully shut down, disconnect from Kafka and the rest. So we're going to give create. Oh, how do I keep? So let's gracefully shut down. Wait, let's shut down. Let's disconnect the producer. Then also let's disconnect the consumer. And the process can now exit gracefully. That's when we detect shutdown. So let's shutting down. So guys, this is it. This is it. We are good to go. So let's test what we did. Then we're just going to check it out. So we have our. Let me bring. Let me you know. Let me shut down this what we have and restart again and restart the servers again. Docker compose. Docker down. So let's bring down the services down. We stop them. You're stopping them. They're stopping them. We start them again, and we now run our application finally and test. I know it's taking more than the time we, we planned. Right. So everything is down, shut down now. If we do docker ps, nothing will show. It's just empty here. So let's run it again. I think the command should be here. It should be here. Yeah, these are all the logs. So let's start again. This time around I will use -d. I don't want to see the logs. So we are starting up everything. So starting created. So Kafka is ready. It's getting ready. It's getting ready. Then when we start, we'll now start our application, right? I've started the Kafka instances container now. So let's start our application. When we start our application will now try to connect to this Kafka brokers and the rest. So to start our application, npm run dev. That's our command to start this command here. So let's wait. Our application is executing here. It's executing these items here now. Start executing it. After logging the message, it's going to start this connection. Try to connect here. It may be successful. It may encounter some errors, but let's see what will happen. So it has started. It's about to start. I mean. Okay. Okay. Our server has started. Server is running on port 5000. So let's see if it's connecting. Okay, it's not connecting to Kafka for now. It's still retrying. Close connection. Still retrying. Alright, it has connected. Kafka is ready. Kafka producer connected successfully. Kafka consumer connected successfully. Still connecting. News consumer started and listening for messages. So yeah, connection is live now. The group coordinator is not available, so we'll give it some time. So consumer stopped. Okay. Alright, so let's do some docker inspection here. Docker ps. Alright, okay, docker is running, the containers are running, right? Yeah, so let's log Kafka, see what is it has. Okay, no, logs Kafka. Okay, these are the logs in the Kafka container, client environment, blah 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 blah. Okay. Connection is good. Hold on. Right, these are two. Let's try. Let's. Wow. See if we still have them running. So everything is running. So let's run a query here. Here I have about like 100 data, 100 data I want to use. So let's check. Let's check our. Let's run a get news. See if we have anything on the data news. So we have nothing. So it's empty array. We have no news yet. So let's create a news item here. So basically, since we are creating 10, right? If I am to process each of these items one after the other, like to run them one after the other, you know it's going to take time, right? Because there are like hundreds of them, right? I think I should hold on. I have like where there's 500 of them, where I ask ChatGPT to give me hundreds, 500 rather. Yes, this is it. So I'm going to take. Let me open it. Going to take the. Yeah, this is it. There are many of them. Kind of funny headline is this. Okay, I'm going to discard this one. Doesn't make the content doesn't make sense. So let me just use this one for demonstration. Alright, let me use it for demonstration here. Then I will discard it. It's just for us to see how it's going to process this 500 data query here. Okay, just for the speed, I will still discard it and use the one I want. But first, I need to save this one. Let me take this one and save it somewhere. Let me create a JSON. Let's call it hood. Put it here. Then let me open that one again. Alright guys, sorry, we just need to test this data. So we have hundreds, 500s of them, right? So let's check and see how well our endpoint is going to process this information. So when we send, click send. Okay, click send. Sorry, something went wrong. Oh, okay, we got an error in our logic. Okay, too large. Yeah, sorry. Entity too large. We need to come here. We need to tell our app to be able to accept large volume of data. And how are we going to do that? Come to JSON, right? Sorry guys, give me a minute. Let me change over my power. All right, I'm back. So we need to specify our limits here. So I think the it's 50. Let's give it okay. Right, so that it can accept large volume of data and JSON as JSON here. So our app is restarting. Let's let it restart. It's restarting. Server is running. Good. Let's see the connection messages to Kafka. Kafka is ready. Producer connected successfully. Okay. Alright, everything is ready. Starting group. Okay, news consumer. Let's hold on a minute. Alright. So let's call that function again. Let's run our query. Yeah, so guys, this is it. Immediately it collected it, sent out the message, news data accepted for processing is published, is discarded. So 500 requests at once, and if you check now, it's being processed in the background. I would even I know I will just put some console log in the processor in the background so that you see how as processing it you see the log, right? You see how everything is being processed. So let's check our list here. Let's check if initially I ran the query and we got an empty array, but if I call it now, we're going to see okay, still being processed. Okay, still giving me error. Let's see, received, publish 0. Wow, publish is 0. Yeah, give me the right message. Let's see why publish is 0. Let's go to our controller. Seems I missed something. Okay, for it to return that message, okay, received, published. All right, let's see which of these got called. Called, let me called A, called B. Okay, so I want to know where the party took. Sorry guys, I don't know why this thing here, maybe I missed something. Or maybe the consumer is already here. Kafka. Okay. Let me even put console log here to see how it's consuming our, yeah, let me do that here. consumer consuming. All right, so let's still starting now because of the modification. Okay, so we're starting up. All right, let's call. First, let's try again. Okay. All right, let's check our console here. Called B, right? Okay. Called B. That means it came here. Okay. That means you have to look here. Why did you Kafka topic and the consumer is consuming from where did you subscribe to Kafka topic also? Wow. Okay. This what's called published. Okay. Connect, send bash. Okay, let me, because this is where it gets. All right, so I need to see why it's. All right, so let's call the function again. Save data, discarded 0, published 0. That's not the proper logic we use. Kafka is ready. Ninjas random distribution. Consumer group. Okay. Send news batch. Okay. Okay. Code new. Supposed to be code. Okay. Okay. Oh my god. Okay. See. Okay. Go provider. I think I've seen where the issue is. I forgot to call send bash here. as well. Honestly, you have to be very careful when observing. Okay, let's see. Okay, startup. Okay, we are good. Let me send out again. Going to publish. Yeah, we've published. Yes, we are good. 500 of them. Yeah. So sorry guys, it was an oversight from me. Should have called the function where I supposed to call it. So if we send, okay, let's wait. Still, why are we still not getting data? Let's check our database. Select everything from news. Okay, okay. Nothing is inserted yet. Okay. Let me remove this. We're getting the. Alright. Why are we not getting data here? Okay, it's connecting. It's restarting rather. Let's wait. Connects. Okay, my blog. Yeah, good. Okay. Let's see why we are not receiving the data. Send to current version. Okay, so let's see the consumer now because producer is cool. Start into news title, the values, we map them into this, flatten the data, cross equal here. Okay, chunk size. Yeah, okay. Consumer run. each message. Okay, let me console log. Consumer run, then what do I need to check? Check the this items. Wow, this is, why is this bug in this place? Consumer is consuming. Let me also confirm that this executes query. Okay, so let's start down. Right, call this again. After code B, we don't get another message again. Okay, after code B, meaning we came here. I need to make sure we actually executed. Okay, see. Current published length. Right, it's called. Current batch length. Let me call current batch. Okay, to investigate this properly. I didn't face this issue when I initially ran this. I need to properly investigate this. Okay, guys. It's taking too much time. I will have to properly investigate this because I'm not seeing any error. Probably it has to do with maybe container, I mean Kafka container or whatnot. We just had to properly investigate. Okay, length. properly investigate why it's not executing. Actually, my consumers are not executing. That's what I'm seeing here, because I'm supposed to see their message when they execute, connect. Supposed to execute, connect successfully, but they are not executing. So I need to know why and investigate properly, guys. So by tomorrow, I should have an answer for us. We'll fix it by tomorrow. Then we'll just test. Then we'll continue from next year's, guys. So please, let's keep it the date next year's tomorrow. I'm going to show us what actually Nest.js is. Then how to transfer some of the code to Nest.js. Then we'll discuss it, guys. So thank you very much for today. Thank you for all. Sorry for the disappointment. Actually, this bug is something we need to look at. When I tested it, when I ran the code and tested it on my system, everything was okay. I don't know why I'm seeing this now. It's not an error because I'm not seeing any bug. It just maybe it has to do with consumer. I will just have to check. It has to do with consumers, or maybe an oversight. All right. So guys, thank you very much. Tomorrow, let's keep it a date. All right. Bye bye.